Dr. Krishna, Professor, EC Department, PSCMR College of Engineering and Technology. So now I am going to discuss about modulation. So modulation concept is very most important. I think this is the heart of the analog communication and digital communication. The role of modulation is without modulation, the transmission is not possible over the long distance communication. So basically modulation means it is the process of frequency translation. It means a low frequency translated into high frequency. For example, I am giving the input signal is 10 kHz. So this 10 kHz is translated into high frequency with modulation. For example, it is converted into 1 MHz or something. So generally, modulation is the process of frequency translation. The low frequency is translated into high frequency. So in textbook, the general given definition is modulation is defined as the characteristics parameters. So modulation is defined as the characteristics parameters of high frequency sinusoidal signal is varied linearly with the amplitude of the message signal. So here I am considering this is as a message signal m of t. So what we are considering in our example, that is a 10 kHz. So how this low frequency is translated into high frequency. So here this is our input signal 10 kHz. Now I am modulating this signal with a carrier signal. So high frequency sinusoidal means a carrier signal. High frequency sinusoidal means a carrier signal. So this is the carrier signal. Mathematically it is represented as a C of t. So this is called modulation. So once again I am repeating modulation definition. Modulation is defined as the characteristics parameters. Characteristic parameter means so this is an amplitude. This is amplitude, frequency, and third one is phase. So the characteristic parameters, which means amplitude, frequency, phase, are varied linearly with the amplitude of the message signal is called as a modulation. For example, we are varying the only amplitude. By keeping a frequency and a phase or a constant. So then the resulting signal is called as an amplitude modulation signal, AM signal. For example, we are keeping the amplitude is a constant and phase is a constant. Only we are varying the frequency. Then resulting signal is called as an FM signal. So here FM signal means only frequency is varied. So here I am representing, this is the positive half cycle, this is the negative half cycle. For positive half cycle, so for I am representing the amplitude modulation signal. So this is the only amplitude is a varied. So here the maximum amplitude we are getting, here very low amplitude value we are getting. Okay. So this is the AM signal. So now we are keeping the amplitude and phase are a constant. We are varying only the frequency. So the resulting signal is called as a frequency signal. So this is the positive half cycle. This is the negative half cycle. For positive half cycle we are getting as a very high frequency signal, and for negative half cycle we are getting as a low frequency signal. So this is a continuously happen. So for low frequency, for positive half cycle we are getting as a very high frequency. For negative half cycle we are getting as a low frequency. So here we are getting only the frequency. So next we are keeping the amplitude and frequency are constant. We are getting only the phase. Then we are getting resulting signal is called as a phase modulated signal. So for positive half cycle we are getting the this is, for negative half cycle the phase is a change. So here we are getting the 0 degrees, 180 degrees of phase shift. So now I am going to discuss about the types of the modulation.